basically 3 chapters of my open source career, which is Gentoo and package management, then GHCup and Haskell core libraries. And I want to go through each of them and then end with lessons learned. So if you don't understand anything or feel free to interrupt me. So this can as well be a conversation, it doesn't have to be me just going through the slides. Yeah, I'm from Germany. I study computer science. I'm a Haskell developer. I do a lot of open source. And yeah, you can also follow my blog. I posted some things about Haskell there if you're interested in Haskell. And my professional career, in the beginning, very boring. And then my first interesting Haskell job was actually in Singapore at Capital Mesh. That was an invoice financing platform. And yeah, since then I work in blockchain, Standard Chartered, and at the moment I'm freelancing for a German company that does chimney sweeper. My open source career basically started as a Gentoo Linux developer. Then later in 2019, I developed the Haskell installer, GHCup. Then I maintain several core libraries of Haskell. There's some interesting proposals that I executed across the ecosystem, like the abstract file path proposal. I'm a member of the Haskell core libraries committee. And well, you could say I'm a Haskell influencer, so to speak. Yeah, what is open source? I mean, maybe most of you know already, but I want to go through it anyway. So basically, it is a group of licenses. You can look up the Open Source Initiative homepage. I don't want to go too much into detail, but yeah, there's some subtle differences between open source license, free software, and copyleft, but it's also interesting to investigate. And well, open source is also a community. It's both volunteers and companies working on it. For example, the Linux kernel is a lot of companies, volunteers, and open source is also a philosophy about sharing, collaboration, and transparency. As an example, I mean, you probably know all these projects. Those are all open source projects, right? And yeah, the Linux kernel, as I said, over 200 companies work on it and over 1,500 developers. And yeah, we have Android, Firefox, Chrome, and GHC is the Haskell compiler, which is across all the open source projects. Most compilers are, but not all of them. I think Swift is not open source. But yeah, so what is the value proposition of open source? So why do open source at all, or why is open source interesting? In my opinion, it's similar to the scientific method. I think even Linus Torvalds said something similar because you want to share your results and have other people replicate them or change it a little bit. So it allows everyone to see what you did and play with it. And open source gives you access to a community. So those are both users and collaborators. And it also gives you access to network effects, I would say. So basically, in my opinion, open source is very fast in terms of adoption, much faster than the industry. So for example, Git, which you probably all use, was written by Linus Torvalds. I think the first version was like a shell script. And the adoption was basically within half a year. Lots of open source projects switched to it and started using it, so the network effects are crazy. But the reality of open source is most projects are abandoned, are in terrible state, have bad code, and are just one developer. So because writing new code is easy, maintaining code is hard. So I would say 95% of open source projects are abandoned. And difficult to contribute to. And that's because most maintainers don't really get paid. They lose interest at some point or get a new job and then move on. So it's not as great as I first told you. Yeah. So that's my first chapter in open source. That's basically more or less how I got into programming. Gentoo Linux, but you probably already know what a Linux is, but I want to go through it anyway. So Linux is an operating system based on the Linux kernel, and it has several core tools around it. Most of the time it's GNU software. And the core system of the operating system is the package management, right? So you want to install software. That's the main reason you use an operating system. Gentoo is a Linux distribution. It is rolling release. That means they're not really, it's not like Ubuntu or Debian. Basically, you update the system all the time. And it is source-based. That means you compile the packages on your own machine. You don't download the binary and install it. You literally compile it on your own machine. So it's quite different from other distributions. It has over 19,000 packages. So I'm not really active anymore in Gentoo, but it used to have 200 core developers and over 1,000 contributors. This is hard to see, right? Oops. Okay. Yeah, how does the Linux distro work? Basically, you have what we call upstream in Linux distributions is basically the author of the library or package like Firefox, the Firefox developers. And downstream is the developers of the distribution, like Gentoo, Ubuntu, Debian, and they basically take the upstream package and start to integrate it into their distribution. That's called packaging. And at the same time, they have to synchronize with other developers in the distribution. There's usually many developers maintaining different things. And the end goal is to serve the user, right? And the user reports bugs back to the packager. The packager may report bugs back to upstream. So it's like kind of like an interplay between these groups of people. And so if you look at a user, here's the user, and the user initiates installation of a package, tells the package manager install something. Then usually the package manager fetches some form of metadata, so what things are available in the distribution. And these are maintained by the packager. And then it executes a build plan or a recipe to install a package on a user system. So then this is the package management boundary. So this is an example of Gentoo ebuild. That's basically the script that describes the package. So it's Bash, as you can see. It's actually a superset of Bash, but mostly Bash. And there are some instructions how to configure the package, how to compile it, and how to install it. So the basics are not very complicated, but if you get into more detail, it becomes very clear. So here you have dependencies. You don't really have to understand this, it's just to show it. And this is basically what the packager does every day, writing these types of scripts, interacting with basically the build system of the package, like Firefox, it can be Makefiles, Meson, different types of build systems. And so the challenges with this packaging is there is no standard build systems, there's like 100. And they all have like small differences, and the packager basically tries to abstract over them in a way, and has to understand all of them. So you have to basically dig into all the build systems that are out there. And another challenge is basically you have different execution environments. So you never really know what is the configuration the user has on their system. They can have different editors or compilers, and the package manager, the installation can interact with that. So it's very hard to ensure that there's never a failure on installation. And the other challenge is reverse dependencies, because let's say you package Firefox, but Firefox uses like 20, 30 libraries, and these libraries are maintained by other people. And if someone there messes up, then Firefox is also messed up. So there's like a complicated interplay between libraries. And so that means basically sometimes very small mistakes have very large impact. And that can be quite frustrating. yeah, as I said, the communication between maintainers is very difficult. And yeah, because there's so many people involved in distribution, it's very hard to execute large changes. Let's say you want to change the default SSL library, which if you remember Heartbleed, the vulnerability, some distros said, oh, we want to drop OpenSSL and use LibreSSL. And then you have to make sure all of the packages compile with LibreSSL, which wasn't the case. Then people started to patch things, and it's like a huge mess. Yeah, but in the end, in my opinion, what a distribution, the job of a distribution is to provide a user experience. That's the only interesting thing. The package manager and all these things are not what you install a distro for, right? So it's user experience. And basically, in my opinion, the plug and play experience is you install a distro, everything works, you install the software you want, and you don't really have to understand how the distro works or who's working on it or all these weird things behind it. So this is the plug and play experience. You don't really care how it works, but it works anyway. But the other thing is, what if things don't work? You want to install a package and it fails. So now the question is, what are your tools to investigate and fix the things on your own? And this is where Linux distributions deviate a lot. Yeah, and basically a distro combines different components to provide a coherent user experience. And if I think about so sometimes I think about what did this chapter of my open source life teach me about programming. I think the main skill in packaging is being meticulous. So you start to look at every line of the build scripts. What do they do exactly, and what would they do on different user systems? So it's not just it works on my machine. You want to work. It has to work everywhere. It has to be portable. And I learned how to maintain. I mean, those are all. It's not very difficult to package in the sense of it's not a lot of code, right? It's maybe 20, 50 lines of code sometimes, but maintaining it for several years and adapting to changes in upstream and so on, it can be very challenging. And Gentoo used to have a very intense rebel culture because, as I said, small mistakes have a big impact. Yeah, so my second chapter then is GHCup, the Haskell installer. First, a short intro to Haskell. Haskell is a purely functional programming language. This is actually a link. You can follow that or Google it. This is basic. So if you're interested in the academic definition of purely functional programming, that paper gives an explanation. It's quite interesting. So, and yeah, Haskell has academic roots. So it started as a language specification by committee. So there were a lot of different lazy programming languages. It was a research area. What is laziness? And then they thought, oh, why not combine all these different approaches into one specification? So it didn't really start as a compiler. It started as, they met, the different compiler developers met and language developers, and they said, let's build a standard. Yeah. And so the main thing about Haskell is basically referential transparency. And that means, let's say you have a function call, and when you have referential transparency, you can sort of, or you could replace the function call with its result. Because that means every time you call the function with the same input, you always have the same output, which is not true in C or any other language where you can have global variables and they can change the result of the function call. That's not possible in Haskell. Yeah, there are a couple of implementations. So GHC is basically the only implementation that really survived. The others are not maintained anymore. And yeah, Haskell is widely used in industry. So in Singapore, I don't know all companies that use it, but I think so. Standard Chartered, I think Citibank a little. Then there's Holmask, I think they do medical stuff or something. It is a common example of Haskell, the quicksort, implemented recursively. So basically you have the termination here, so when you have an input list of, I don't know, integers, and the input list is empty, you have to terminate the recursion somewhere, right? Yeah, basically very straightforward. How the recurses. You have the left side, you filter all the things that are smaller, and you have the right side, and then it just recurses. But you know, it is not really quicksort. So it's basically a lie. If you can follow the link, and real quicksort has to be in place. So, this is not very efficient, but it's a common example of how elegant Haskell can be writing algorithms very elegantly. Yeah, so this is basically GHCup. There's a terminal user interface. It shows you the different tools of the Haskell toolchain. GHC, the compiler. Cabal is the build tool, like Rust Cargo, for example. Then you have the language server. I don't know if you know the LSP protocol in VS Code. So Haskell supports that. Stack is another build tool you can use. And yeah, so why did I write this installer? In 2019, when I worked here at Capital Match, we had people working in different platforms, and there was no one Haskell installer. Everyone was doing it either manually through the distribution, but then you get sometimes different versions, or you know, it was quite difficult. And yeah, so the first version of GHCup was similar to JIT, just a public shell script, 106 lines of code, and it was heavily inspired by Rust Up, at least the interface. And today, this is the Haskell. So Haskell has a survey, or used to have, where they ask users how do they install Haskell, the Haskell compiler. And 3 years ago, it was 55% used GHCup. So basically now GHCup has over 17,000 lines of Haskell code. It supports all platforms, including Windows, FreeBSD. And so it's basically now the first thing Haskell developers get exposed to. Yeah, so if you ask me what is GHCup technically, you could replace it with this shell script. You basically just download the Torval, unpack it, run configure, make install, and clean up after yourself. But of course, now it does a lot more than that. And basically, what it does is, I mean, it is an installer, so it has this the activity of installation, but it's also conceptually a distribution channel. That means a distribution channel basically is like kind of like a QA gateway between, let's say, for example, GHC developers and the end user. For example, I test the binary distributions, the powers, and if there's a bug, I fix it before shipping to the user. So there's some, it's more than just installing. There's more going on, and I basically have to be involved in release processes of the other tools like GHC Cabal, and I also have to make a decision which version to actually install by default, because there are a lot of GHC versions. Yeah, and that's actually very difficult, because sometimes one GHC version works very well on one platform but not on the other, and then you kind of have to figure out, well, what is so my idea is usually, what if 200 students have a Haskell course and they want to install GHC, and on all platforms they have to have the same version and it has to work well, and that's basically the idea. Which version should we recommend? Yeah, and as I said, so I have to talk to GHC developers, Cabal developers, HLS, and yeah, basically, so those are the things I depend on. The release frequency of GHC affects me, and the platform support. Sometimes GHC developers, for example, the compiler developers, they want to drop support for a certain platform, and then as a distributor, I can basically kind of try to push back and have a conversation with them. So there's a lot of communication going on. And basically, those are the people that depend on the installer. Those are obviously the Haskell developers, but not just those. So we also have end users, like people who want to compile a specific program, like Pandoc. And then they also need the compiler to install it, right? So it's not just developers that are using the installer. It's used in continuous integration and other tools as well. And yeah, what are the programming lessons from GHCup? I would say, I mean, I wrote it from scratch. So basically, how to write a single purpose program from scratch with a very specific purpose. And most of it is command line interface, right? And then what is the intuitive command line interface? It's a very difficult question because you don't really care about the installer on its own, right? It's not like, oh, I want to have an installer. No, you use the installer to install something. So you don't care how it works, how the command line interface looks like. You just want it to do its job. So it has to be very intuitive and then get out of the way. And the other thing is, most of the time, I used to work on this project alone, so there was no one to review my code. And then I started to review my own code. So we just, on the weekend, sometimes go through the code and look for bugs. And there was actually one pretty severe bug that I found one day. And yeah, that was quite interesting. So I constantly have to think about ways to improve the reliability, because if the installer messes up, it can damage your files on your computer, and that's a really bad experience. Not just a bad experience, and people also say, "Oh, look, Haskell is shit," or I don't know.
So, what kind of bug was it?
There was a bug where it would clean up. So it was very hard to trigger under certain conditions. So it would install into an isolated directory. There was already a different feature, and then we'll try to clean up and then delete the wrong directory recursively, right? That's basically the worst case that can happen. And when I saw that, but no one ever triggered it because it was like multiple conditions had to be met. And the way I fixed it then was to encode in the types whether it's difficult to explain, but let's say there's a directory a GHCup installs. It's like on a home.ghcup, and I would have a type that would tell me the subdirectory is under this .ghcup directory, which we control. But then there are directories outside of it that are, for example, not in home, and those have a different type. So it was impossible to delete directories that we don't control, basically, right? And I did it on type level, and then basically the bug is impossible to trigger anymore.
So it used to be where the deletion can jump out and delete all the other files on top.
Yeah, depending on where you install. So there was a feature where you could install into a directory that is not .ghcup. That was used in some CIs. And then there was a cleanup that would only trigger when there's an install failure. So you would have to do an isolated installation in a non-standard location. And then there were two more conditions that had to be met. And then it would recursively delete. And then basically I had to rewrite large parts of the code base to have this information on type level, basically. And there were other things I was considering, like using a syscall sandbox to then test in CI if the behavior is sound. So there are some syscall sandboxes where you have a wide list of directories that your program can write to, and then I think it's I forgot what the Linux kernel thing was. Yeah, I can't remember. But anyway, so then the program would crash basically. It wouldn't allow to execute. But I never implemented that because yeah. Yeah, and right, so that was like almost the worst case to happen, and then I basically also so today there's another company, Obsidian. They basically help me 20 hours per month around to work on GHCup, do reviews and so on. And they are paid by the Haskell Foundation, which is a non-profit organization. So they don't have to do everything on their own. Yeah, so the differences to Gentoo are basically, GHCup deals with installation, Gentoo deals with installation, but one is basically a Linux distribution with a package manager, and the other is just an installer, right? And so in GHCup, there's way more code to maintain. And as I said, it's mostly a one-man project, and it's much more challenging. I don't have 200 other developers who I can ask what to do. And the coupling is much tighter between the tools I support and the installer, right? And interesting is also I basically found myself in a position of authority, right? Because I can, for example, decide, as I said, what is the default GHC version to install. And through that, I could basically also push back to GHC developers and say, I don't consider this version stable enough to expose it to users by default. And then there's kind of like a conversation between us. So yeah, the third chapter is Haskell core libraries. What are Haskell core libraries? They're bundled with a compiler, with a GHC compiler. And they're fundamental building blocks, so primitives like how to deal with file paths or text or byte string. And then there's the base libraries, basically the stand-up libraries, so to speak, and it's available to all programs by default. These are the core libraries I maintain. Basically the challenges of the core libraries is that if you change something, if you change API, everyone in the ecosystem, like every Haskell user basically has to pay for the things to change. And if you break API, everyone has to adapt. So, and then you get bug reports, not bug reports, you get responses from users, and they're very angry, and then because you can basically cause damage for projects, force them to migrate to a new version and so on. So those are new things to consider when programming. And writing primitives is actually quite hard, because those are not really specific APIs, so you don't really know how will the end user use your APIs. There's lots of port knowledge involved, so I have some examples here of Windows file paths. For example, did you know this is a valid Windows file path? And does anyone know what it means? See this one? So there's no slash. So it's basically, it's a relative directory in the current process on the drive C. So it's actually a relative directory. And this is UNC path. I don't want to go into details, but yeah, so you can basically write an BNF Bacchus now form for Windows file paths because they're so complicated. So portability is really difficult. Yeah, the core libraries committee has 7 members. It basically manages the API changes of base and nothing else. So it doesn't really maintain other core libraries, only base. And if you want to change anything in base, it requires a proper proposal, an impact assessment. So you basically have to compile parts of the ecosystem with your change. And yeah, you have to have implementation. We don't vote on anything unless there's an implementation. The core libraries committee also ensures that other core libraries have active maintainers. And so there was a file path proposal where basically this is, I don't want to go into too much detail because it's quite complicated, but so this is basically kind of the file path type in Haskell. It's a linked list of Unicode characters. So it's not UTF-8, if you understand the difference between Unicode code points and encodings. I don't want to go into too much detail, but it's basically a very inefficient way to represent UTF-8 or any Unicode. And the abstract file path proposal tried to improve that by using actual raw bytes and not changing the bytes from the system calls, which is much safer when you have like network devices and so on. There can be edge cases. But now the problem is the file path type is in base in standard library. And I can't break the API because then it will break the entire ecosystem. And now the question was, how do I drive changes across many core libraries across the whole ecosystem. And yeah, there were two options, basically do it in base, break everything, or do it kind of like in user space as a separate library. But that has the downside that, okay, now you have two file path types. Yeah, and we chose that path because it's less expensive, but it's harder to gain adoption, right? And there's no high authority. So what to do if you want to drive changes across core libraries or an ecosystem? You have to build consensus, you have to convince many maintainers, you have to write patches, and then one person can block your entire effort because there's the chain of libraries that work together. And it's a sort of politics, and you need people who support your idea, otherwise you can't push anything through. Yeah, so the lessons from core libraries is how to design good primitives, so, as opposed to abstractions. Abstractions is different than primitives. Because primitives, you don't really know how they're going to be used. And how to consider the impact of API changes, right? Especially when working on the Unix package, which is like a lot of POSIX API. I realized that sometimes I look into a function and it's very weirdly implemented, and I think, well, that can't be right. And there's no comment explaining why is it so weird. And then you basically have to assume there was a good reason and go to the Git log or ask people who have been around 10 years ago, because otherwise you might break something. Yeah, now to the last point, lessons learned. What have I learned? Collaboration is one main lesson. The main currency in open source is, in my opinion, energy. It's not, it's not money or what is driving open source. It's not even what is technically the best thing to do. No, it's someone sitting at home, having an idea, and they have energy to do it. And that is the currency. Yeah, in my opinion, you have to treat computers like kings because they are rare. So if you get computers, treat them well. Don't do like really strict reviews. And they will get bored or annoyed and then just leave. And then they're gone. And be mindful about boundaries. That's a tricky balance. Yeah, so you want to collaborate, right? But you also want to keep your boundaries. So sometimes it can happen that you do things and then other projects start to rely on it, but it's actually not your job to do. And then sometimes you have to push back and say, this is not my job, this is your job to do. And it can be very, very tricky balance between collaboration and maintaining your own boundaries. And what I also learned was that it's always good to respect other projects' workflows, even if you think their workflows are bad. And even if you have good arguments, you want to get your passion, so just follow whatever they do. And yeah, driving large changes requires a good value proposition, an execution plan, building community consensus, and you need support from people who are also maybe respected in the community. You can't just do anything on your own. Yeah, the Haskell Foundation is basically an attempt to help with this, to help with driving changes across the ecosystem. And it can also, the university in theory can also support the Haskell Foundation. So if anyone with authority from the university, they can contact the CEO of the Haskell Foundation and talk to them. Yeah, another lesson is project maintenance. Yeah, contributors. It's so hard to get contributors. And so dictatorships work. So GHCup is kind of a dictatorship. I do all the decisions. But it's not sustainable because you don't, I started in 2019 and after 5 years we started with energy. So you have to find people who are excited about the project, who can make good decisions. And after a while, you basically, in Germany, I don't know if that's a proper English word, but we call this organizational blindness. That means there are things in the project that should be fixed, but I've been doing it for so long, I can't really see them anymore. Like, I don't know, broken CI or tests missing here and there or small things. I work around anyway, and then I think, oh, my time is better spent elsewhere on features or something, and then certain things get never fixed. And you have to actively think about the contribution experience, because the contribution experience decides whether a contributor comes back. So they might try to patch once, but you want them to come back, right? And that can be, I don't know, thinking about documentation, how do you tutor someone, or, you know, even if is your code pleasant to read? I don't know. Sometimes it's not. And yeah, when you have contributors, one thing is you need decision-making processes, right? Sometimes you have to say no or yes, but in my opinion, you should have a good process for that. If the decisions are high risk and you can't easily revert them, you need like an elaborate process how to make the decision. But if the risk is low, you should make a quick decision. So otherwise it becomes bureaucratic, and then you annoy the contributor and they lose energy and then they stop contributing. And the last thing is how to maintain the project vision. That is something I don't know myself either yet, how to do that. Most open source projects that I know where the initial developer left did not manage to maintain the project vision. It kind of changed. Maybe that's a good thing, maybe not. I don't know. Yeah, user experience is another lesson. In my opinion, user experience is harder than computer science. Because it's very fuzzy. It's not, you know, if you don't have like mathematical problems, you can't describe them well. They can be different in different cultures or different user groups and so on. But in my opinion, the three pillars are plug and play experience. So it's about intuition. You don't want to have non-intuitive interfaces. Then the happy path. What if things go wrong? Are you able to give the user enough control to fix it? Or what can they do? Where do they get help? And defaults is basically about expectations. So what is the expected behavior when I run the program? Does it do what I would expect, or does it surprise me? It should never surprise me. And in my experience, yeah, toolchain is often like a holistic user experience, because you have different teams working on different parts of the toolchain, like the compiler, the build tool, and they don't really talk to each other a lot, especially not about user experience, because it's not like an academic thing to do, or, you know. And then there's no one really maintaining a vision of what is the whole user experience. And the longer you maintain something, the more if you had a user experience vision, it gets easily lost in your daily maintenance work, because you focus on features, maintainers change, or you do collective decisions to committees, and then no one has a user experience vision anymore. And yeah, stability versus progress is basically a problem that runs very deep in the Haskell community. As I said, historically, the compiler was basically a research project where the type theories would be tried and so on. But in recent years, there were more pushback from the community because they have to pay for the breaking changes in the language. So there was a post from a Facebook engineer who said, so Facebook uses Haskell, they kind of have a fork, not really a fork, but they have their own patches on top of it. And they said it takes one person a year to upgrade to a new GHC version for them. And that's because of all the small changes that add up, right? And well, and that basically triggered a chain of discussions and so on. And I think after like 2 years, the GHC developers wrote a policy document about stability guarantees in their release process. So it was, in my opinion, like a major milestone where the compiler developers started recognizing that stability is an interesting goal. Because before it was just progress and better language features, but now they are trying to manage both. And it is a very difficult issue, how to maintain stability and still make progress. Yeah, and composition is, Haskell is a functional programming language, right? So, of course, I like composition. So, in my opinion, there are different categories of composition. You can have like a function level, which is obvious, you compose functions. With libraries, it's a little harder how to write a library that is composable. that depends on the language. Does your language allow to write interfaces and implement them abstractly, like type classes or something else? That's quite hard of an issue to solve. But there's also composition in terms of programs, and in my opinion, that is the Unix philosophy. So basically, you have one program, it does one thing, and then you pipe it with other programs. Like you all probably have written cat, pipe, grep, and whatever. And that's basically how you compose programs in Unix, basically through standard output, standard input. And it's a very simple idea, but you can achieve a lot of composition through programs that don't really know what they do. I mean, you don't write your program and know how someone else will use it, basically, right? But it still fits into a composition. And there's how to make your project composable. There's a website here that goes into like a lot of detail, how to design command line interface tools and what is the right way to write a command line interface. It's very it's very interesting to read. Yeah, that was it. I mean, questions, arguments.
So when you are maintaining all these open source projects, right, definitely a lot of end users or like developers using it would like suggest changes or like features to add inside these projects, right? So how do you decide which ones are the most important, and how do you decide which features to add?
Yeah, that's a good question. How do I decide which features to add? I mean, I try to think about how many users does it affect. And it's I don't know, over the years we developed some form of intuition, and basically it's very hard to answer. In the end, I rely on my intuition, because sometimes you have to push back because a feature might make sense to the end user, but it actually conflicts with your original vision, right? For example, one of the visions of GHCup was that GHCup will never interact with the system package manager. There's some reasons for it, and then it has some user experience effects that the user has to actually install the dependencies themselves. I don't do it for them, but that's because I find that those are the correct boundaries. I don't want to execute with pseudo rights to a package manager. What if I get it wrong? So I just don't want to do it. And then if people ask, why don't we do it? And I constantly have to explain it. So that's why these points are written down on the GHCup homepage as the things that I will never do, basically. Does that answer the question?
Yeah, I think following up on your answer, the voting votes vote on certain features.
Sorry again?
You were saying that you can't decide which one is a good feature and which one is which are not, right? So does voting for a feature work in this system? I mean, the user vote which feature they want.
Yeah. So the user they don't really know what's good for them.
Yeah, I mean, yes. I mean, this group of user knows. I mean, the user to some extent they know what's good for them, but for this group of user. That group of user who think that feature is better. So does voting in this sense help to get the feature that the community wants?
I'm not sure I understand the question exactly.
I mean, the community actually vote on the features that they want. Does that help to get features? Helps choose them.
I mean, the community feedback is of course important, yeah. But I always try to figure out is it still within the boundaries, right? So sometimes they want features that make sense, but then GHCup as a project, for example, is not single purpose anymore. Then it would do more than being an installer. And then the question is, why did you write in a new program to do that? So I don't know if that answers the question.
I think there's like a space for suggestions, right? Because I saw in the repo they have like discussions.
Yeah.
So I know some developers who use that like discuss on like certain features, changes and whatnot.
Yeah. So the discussions happen everywhere. There's a Haskell discourse where there are discussions. I talk to developers, and I also asked, for example, the Haskell Foundation about, because sometimes it's difficult for me to get feedback. For example, a university has a Haskell course, right, and 200 students use the tool, but I never know what problems they face. And there's an issue for me because I don't know what to improve. And then one time there was a lecturer on my issue tracker in a university in America or whatever, and there was an issue with installation on Windows. And I was so excited because especially Windows users often don't really, write bug reports. They just, I don't know what they do, but they don't write bug reports. And then I was excited. I tried to communicate and figure out what is the problem.
If there's something that's like not Haskell, but something in Python. Because they used to many years back. They had the short exe installed, or was it MSI? Like
That's the platform.
yeah, like they had the
Yeah, I know.
because the Python MSI had they used to hard code the repository to the directory to install it.
Yeah.
So the option to like select the drop down, didn't do anything. So Python would just install to the hardware directory.
Yeah.
So when I told them about it, then they just change it.
So there was also discussion about is the user experience on Windows a good experience because there's no MSI installer for Haskell anymore. There used to be one, I think, the Haskell platform, but it's not made anymore. And that's something I'm not very knowledgeable about MSI, and I'm not paid, so it's something that it would make sense, but
there's some tools, but like never really tried. But I think you could imagine like then you sit out there like try to like support all of them and then
that's definitely a good thing to do. It's just who's can do it.
So I think you mentioned that GHCup was created for work, right? It was a problem that you had at work. I guess at some point they graduated to an open source project. I guess how did you kind of manage that relationship? Were they happy for you to maintain it as open source?
No. So I didn't write it for my employer, so it was open source from the beginning, and I made that very clear. And I didn't really work on it at work, at least not officially. So it was open source from the beginning. There were a couple of people who were interested in the idea, and then I basically found someone from the Haskell.org Foundation. That's a different one. That's not Haskell Foundation. It's Haskell.org is about the website. And there were people saying, "Oh, this is a cool idea," and they basically wanted to promote it through the main Haskell website, the tool. And it was very early on, and I think that was one of the reasons why it took off, because of the network effects then.
When designing for the happy path, are there any things that you learned over time that are good general rules? And the kind of a reverse question: have you seen something behavior so unexpected to be a default that surprised you? Why is the default?
So the happy path is basically my work on Gentoo is basically I have to go a little bit further back. So Gentoo is a source distribution, right? And it is basically written for the case that things go wrong. Because in Gentoo you can easily change a package and compile it again. So for example, the packager makes a mistake, it's easy to fix in Gentoo. If you're on Debian, you can also, but it's a little more involved. And so Gentoo was basically developed to have the most control over things when things go wrong. And I think, so I try to have that principle in GHCup as well. So for example, on Windows, the installation is actually carried out by 3 different components. A PowerShell script, which is quite large. then a shell script. So the PowerShell script installs MSys2, and that then executes a POSIX shell script, and that POSIX shell script then will execute the GHCup binary. So there's like different components. And yeah, if something in the middle fails over, like MSys2 installation or whatever.
Yeah, indeed. Someone reported the issue of that last year. Last year.
Yeah. Yeah, so basically what I did in that case was I documented how to install everything manually. Basically a documentation. This is conceptually what the PowerShell script does, and you can do it manually, and then you can debug properly which part is actually failing. And because then you can do it manually, you can do it also in different ways. The PowerShell, so the script has to make a decision which MSys2 version to install and how exactly, in different ways. And so when you have a documentation, what are the exact steps, then user can execute them, which is annoying, but that is what on Windows helped in the case we deviate from the happy path.
Hi, so I have a question about the cybersecurity aspects of open source projects. So like for context, right, recently there's another open source project called GHCup, where one of the core maintainers was discovered to be a malicious actor, right? And he was contributing to the project for like 2 years before he decided to sneak a backdoor in. So then the original maintainer, right, had to like step in and like work overtime. So like my question for you is like, given the importance of GHCup, right, how do you guys know like which maintainer to trust? And like how do you guys manage the transition process between maintainers? And a follow-up question is like, what are your thoughts on the level of responsibility that the original contributors have to maintain and update the repo?
Yeah, so the main so GHCup has two repositories. One is the GHCup binary, the installer that has all the command interface, and then a repository called GHCup metadata, and that is a YAML file that lists the versions of GHC and all the tools basically. And that is also has the URLs to the binaries we install. And they are secured by hashes and so on, blah, blah. But so basically the interesting question is who has access to this metadata repository? Because that is the point where someone could say, oh, download this GHC tarball, which has something malicious. And there is GPG signatures for every file. And the signatures are documented on the GHCup website. And very few people have full access to this repository. So it's me and I think 4 other people. And most of the other people that have access are GHC developers. So I don't easily give access to anyone. Only if I have seen them in real life, which I did. So there's a ZuriHack meetup in Zurich every June. And I met all the people who can push this repository there. So for me, I mean, the only way is to build trust. You never know what someone's up to, but yeah, I don't just give access to random people. I don't know. Is there another way to secure? I don't know.
That's not the only thing. There's other ways where, like for instance, the small project maintainer wants to sell it, and then the malicious actor buys it out. Happens a lot in like code extensions and Firefox extensions.
Yeah. Any other questions?
Have you ever tried that GitHub sponsors before? And how it's if you try the how it's really awesome.
GitHub sponsors.
Yeah, like you're saying that like sometimes some things you don't do because it's like let's say like don't have enough support and funding and so have you ever tried GitHub sponsors?
Yeah, so GHCup has an open collective which is similar to GitHub sponsors, right? And I think we raised 1,000 euros. How much? I think about 1,500 maybe. But it sounds a lot, but it's over, I don't know, almost 4 years. So, I mean, how much does it cost for a senior developer to work on something for 2 weeks? That's not even enough for 2 days, I don't know. Yeah, so it's basically it's more like a gesture, and I sometimes I mean I could theoretically use it for CI, for example, but CI is actually paid for by the Haskell Foundation. But yeah, it would be interesting to have like bounties or something like that for certain features. So the Haskell Foundation actually has a repository that's called Tech Proposals, and you can basically ask for funding from the Haskell Foundation. And you can say, oh, I want to work on GHCup or on a compiler or something else, and they might actually sponsor you if it's a good proposal. So GHCup on its own doesn't have this because it's hard to, so, but it's possible to the Haskell Foundation.
Yeah.
As a maintainer of field libraries yourself, what gives you the energy to continue like being a maintainer? Like, is it some passion or like responsibility or some other driving factor?
Good question. It's rage. Yeah, I think no, I'm being serious actually. So most of the time, so why did I write GHCup? Because I looked at the ways to install the Haskell toolchain and it was all a mess, and I got angry, and that's where I got my energy. But I mean, you can't run on rage all the time. So at some point it switches to like a feeling of responsibility, and then so if I stop tomorrow maintaining GHCup, I don't know what's going to happen to the project. It'll probably die out. It's at the moment it's more a feeling of responsibility. Yeah.
Are there any questions? Yeah, right, I guess you can start that.
Yeah.
So can you round of applause for
Lovely.